Now, an immediately following question here might be, what if I wanted to go from Corvallis to Portland? Graphically, that's really easy to do because I can just go look at the dots that I have down on the map, and I could draw a vector. In fact, I might choose a different color. And I could draw a vector that points from Corvallis up to Portland. So that would start here and would point like this. And that is a different vector. It's no longer a position vector because it's telling me something about the change in position or the difference in position from one place to another. So I might decide to come over here and give a new name here, and I would call this the displacement vector. Displacement. And we'll typically write displacement using standard math convention, which is to say that this is a change in the position vector, something like delta r. So this delta, capital Greek letter, that tells you that you're looking at a change, typically a macroscopic change. And you can represent it as the final position minus the initial position. And this is the general equation. The specific instance here, I'm trying to go from Corvallis to Portland. So that means that RC would be my initial vector, RI, and RP would be my final vector, RF. And then this here would be my delta R. And I'll probably just leave this usually as delta R. But you can imagine doing something like delta R CP as subscripts that tell you you're going from Corvallis to Portland. But you don't always have to do something like that. In general, you can see that this expression is a difference. It's subtracting one vector for another. And if you have your original position vectors really nicely laid out like this, with the two vectors with their tails together, in this instance at the origin, it's very easy to find the difference or the change between two vectors because you simply have to draw the vector that I would add to the position that Corvallis is at, which is RC, that would end up giving me the position vector of Portland once I've added those two together. So here you see RC plus delta R gives you RP. And that's an alternate way that you can think about writing an expression like this one down, right? Is that if I took the initial vector and added the displacement vector, I ought to get the final position vector, right? And here all I've done is rearrange this expression by adding RI to both sides.